Hey students, this video is going to go over an introduction into stoichiometry. So first off, I want to talk about that little intro lab I had y'all do yesterday. So you were looking at mixing some baking soda and vinegar in different quantities to see how that changed the inflation of the bag. And so I had you do the experiment 4 different times with 4 different quantities of baking soda. We did keep the amount of vinegar the same because any good experiment needs to just change one variable at a time. And hopefully you saw the bags inflate differently depending on how much reactants we had and the quantity, the ratio of those reactants to each other. I want you guys to think about this. What do you think would have happened if I had you do a 5th bag that had 2 teaspoons of sodium bicarbonate instead of just 1? So if we doubled the amount of sodium bicarbonate, but we kept the amount of vinegar the same, what do you think would have happened? Well, hopefully, based on your observations, you would know that nothing else would have happened because there should have been some extra baking soda that you saw in that last bag, some of the baking soda that did not react. So adding extra baking soda really shouldn't have changed anything because you would have just had even more leftover baking soda. So we're going to take a look at our balanced reactions for a second. Yes, we're going to have to balance chemical reactions in this unit. You're going to have to write reactions. We're going to use those reactions to do our stoichiometry. So when we're looking at our balanced reaction here, let's go ahead and put some coefficients here. Balance the oxygens, balance the hydrogens. When you're looking at that reaction, it's basically telling us that 2 molecules of hydrogen can react with 1 molecule of oxygen to produce 2 molecules of water. But we usually use those coefficients to tell us about the mole ratio. We can also say that 2 moles of hydrogen reacts with 1 mole of oxygen to give us 2 moles of water. So we can say it in either of those contexts. All right. I do want to show you something. I'm going to use this simulation down here. I have to stop sharing this screen. And I'm going to go to this PhET website. And you are more than welcome to get on your own and play around with this and see how it works. I'm going to go to molecules here. We're going to make water. So up here, you see that we have our balanced chemical reaction, 2 hydrogen molecules reacting with 1 oxygen to make 2 molecules of water. So when I put in those coefficients here, you can see that I've got 2 hydrogen molecules. I've got 1 oxygen molecule, and I've made 2 molecules of water. But the question the PowerPoint asks, what's going to happen if we use 6 molecules of hydrogen? So let me just add these here. You can see that over here after the reaction, it's just kind of piled up here as extra. We can't make any more water yet because we don't have any more oxygen. But if we add up to 3 total molecules of water, you can see as I add the oxygen, the extra hydrogen bonds with that oxygen to make water. So for every 2 hydrogens and 1 oxygen, we can make 2 waters. So since our coefficients have tripled, the amount of water we can make at the end triples. Okay, let's look at the next question, which is about the ammonia. Here's our balanced chemical reaction for ammonia. This tells me that 1 nitrogen molecule, let me add that in here, reacts with 3 hydrogen molecules, let me add those, to make 2 ammonia molecules. And you can see that we have 2 ammonia molecules over here. So what's going to happen if we have 2 nitrogens? Now you can see when I added those 2, they're just extras. They haven't reacted yet. And I go up to 6 hydrogens. Adding just 1 doesn't do anything because I don't have enough hydrogens yet to make an ammonia. I've got to add some more. And you can see that I was able to make 2 more ammonia molecules. Okay. So when I've doubled my coefficients, when I've got twice as much nitrogen and twice as much hydrogen, I can make twice as much, so 4 molecules of ammonia. Stop sharing this. Go back to the PowerPoint here. Nope, that's not it. And so we did this one already. So that ratio of reactants to products is called stoichiometry. We're quantifying the amount of reactants and products we have. And so when we're planning out our labs and everything, we are doing some stoichiometry to figure out how much of this reactant I need to react with this reactant so that I can prevent some chemical waste. If I need to end up with a certain amount of product at the end of the reaction, I can do stoichiometry to figure out how much of each reactant I need to end up with a certain amount of product. So we're going to be using those coefficients in a balanced chemical reaction to help us get that ratio between the reactants and the products. So our stoichiometry is basically just like our chemistry recipe. So here we have a recipe for a smoothie. It says 1 banana and 5 strawberries is going to give us 2 smoothies. So how many smoothies can I make if I have 2 bananas and lots of strawberries? So it's just like that simulation I was just showing you. If I have twice as much banana and lots of strawberries, I'm going to be able to make twice as many smoothies, and I can make 4 because the ratio is 1 to 2. Now, what if I had lots of bananas? I'm not going to run out of bananas, but I only have 25 strawberries. How many smoothies can I make? Well, if I have 25 strawberries, I have 5 times as many strawberries. So I can make 5 times as many smoothies. So I can make 10 smoothies. Okay. And that's what stoichiometry is, just looking at those ratios, looking at those coefficients. All right. We're going to go on to the next video to talk about mole ratios and using those coefficients in a balanced chemical reaction.